Okay, this video is our in-class practice and on logs, and it's 5.2 number 2, where we practice a lot with half-life and doubling time. And I just want you to know that most of the time I will say the word continuous, but if I don't, if I say half-life or doubling time in the question, then you can use the continuous formulas y equals a e to the kt. And the reason why I say to do that is because it is so much easier to use. So let's look at the first one here. Find the half-life of a radioactive substance that decays at a continuous rate of 27% per minute. First of all, they told me the rate, and they did say continuous, so that's good, and they want me to find the half-life. If it decays, I know that if the rate is 27%, I know it's going to be negative 0.27 when I put it in my formula. So I'm going to say y equals ae to the kt, and then I'm going to put in that rate. Okay, so that's my formula, but what bothers everybody is they never told me my initial value. But it doesn't really matter. It says find the half-life, meaning you want to know how long it takes for half to go away. So if I start out with the amount of A, I want to know when there's a half of A left. Whoops, a half of A. A half of A left. So I'm going to put 1/2 of A equals AE to the negative 0.27t. And then when you actually go to solve this, it's so much easier because I can divide by A. Thanks for playing, it's gone. So I have a half equals E to the negative 0.27t. And I'm solving for t, so I can natural log both sides. And when I do, I can say thanks for playing. So I know the natural log of a half equals negative 0.27t. And if I go through and divide through by negative 0.27, okay, then I've got t equals the natural log of 1/2 divided by negative 0.27. And when I put that in my calculator, I get roughly 2.57 minutes because it was in minutes. And the one thing I want to let you know is it doesn't really matter what I started with. It really doesn't. It just knows that no matter what I start with, that it's going to take 2.57 minutes for half of it to go away. So let's look at our second one here. It says find the half-life of tritium that decays at 7.452% per year. I didn't really say continuous, but you could use the continuous formula, and I would be fine with it. But because I didn't, I'm going to do it without it. So I'm going to use y equals ab to the t. So if I want to find the half-life, I do know the rate. I got to remember that if I'm doing this without the continuous formula, I know that it's decaying, so I have to do 1 minus my rate, or that's 1 minus 0.07452. When I do, this is what I get. Y equals A, and it's 0.92548 to the T. Now, I do know that I can now do the half-life of this. So I can say, oh, I want to know a half of A equals A 0.92548 to the T. And when I divide the A's out, they're gone. So now I'm going to say 1/2 equals 0.92548 to the T. I'm going to natural log both sides. Now, by using this formula, you can't really cancel anything out. So I know that t equals the natural log of 1/2 divided by the natural log of 0.92548 to the 548. And when I put that in my calculator, I get about 8.95 years or 9 years. Now, I actually did this in class with everybody, and I'm saying if you want to do this, with the exponential, with the continuous exponential, you would get full credit as well, even though I didn't say the word continuous. And when you go through and do it that way with y equals a to the kt, you get about 9.2 years. So it's not much different. And I would give full credit for that. So you can always use for half-life and doubling time the continuous formula. It makes it a little bit easier, as you can see. Okay. So let me clear the ink from this page and do number 3. So when I do, it says find the doubling time. So doubling time is basically how long does it take for something to double. So this one I did not say continuous, which you could do it that way. So I'm going to do it as y equals a b to the t. You could do it continuous as well. And if it's doubling, it's growing, that's 0.07. So I know this is 1 plus 0.07 because it's 1 plus your rate. So I'm going to put 1.07 in for b. So I have y equals a 1.07 to the t. So they gave me the rate, so that makes it easy. Now when I go through and actually solve it, I can say 2a equals a 1.07 to the t. Thanks for playing. So I have 2 equals 1.07 to the t. Now I can natural log both sides. So I have the natural log of 2 equals t natural log of 1.07. So t is going to be natural log of 2 as I divide by the natural log of 1.07. And when I do, I get roughly 10.2 years. If you do it exponentially, I think it comes out to be either 9.9 or something like that, the continuous, and it's perfectly fine. Okay. This one here, I actually say it tells you it's continuously growing. So I'm going to do continuously y equals AE to the KT. And it's doubling time, so I know that this is going to be my K, and it's going to be positive because it's growing. So I can start right off the bat saying, oh, I want to find when this doubles. I already know my rate is 0.1427 to the T. So I can do it this quickly because I know the rate. So I go, thanks for playing. So I have 2 equals E to the 0.1427T. Then I can natural log. So this is the beauty of using the continuous, base E. So I have the natural log of 2 equals 0.1427T. And then when I go through and divide through by that, I get T to be the natural log of 2 divided by 0.1427. And that's roughly 4.86 years. So I've kind of showed you both ways. Like I said, anything with half-life and doubling time, go ahead and use the continuous. That's fine. Okay. Now 5 and 6 are kind of more the level I want you to be at. So the first 4, the reason why we were able to do them so quickly is because I gave you the rate. 5 and 6, I would star these because you're basically going to come up with the rate yourself. So this first one says I have a population and it's growing from 10,000 to 13,000 in 3 years. Assume the growth is exponential. They want me to find the annual rate, which is y equals AB to the t, is the formula you're going to use, and the continuous is y equals AE to the KT. So the cool thing here is you can find one or the other and then convert it to the other, because I do know that B equals E to the K. That's really important. So what I decided to do was to do letter B first, because it's easier to do B first and then convert it to the other formula. So we're going to do B right here. So B is y equals AE to the KT. And then when we get done, we have to figure out why the answers are different. So this population is growing from 10,000. So that's when time is 0. So you can say, oh, that's the 10,000. Okay. And it grows in 3 years to 13,000. So there's that point too. So you have time and population. So I know that A is going to be 10,000. So I have y equals A, is 10,000. Sorry, I just said it, is 10,000 E to the KT. So now I'm going to plug in the 3 and the 13,000, because this is time and this is my y, or my population. So I'm going to say 13,000 equals 10,000 E, and I'm going to put the 3 here, but switch their places to the 3K. Okay. So now when I go through to solve this and divide by 10,000, I'm just going to get rid of all the zeros. You end up with 13 over 10 equals E to the 3K. Now I can solve for K by natural logging both sides. Thanks for playing. And that's kind of why I picked this one first. So the natural log of 13 over 10 equals 3K. K is going to equal natural log of 13 over 10 divided by 3. So that actually comes out to be for that is 0.0875. So my continuous formula really is y equals 10,000 e to the 0.0875t, and that means my continuous growth rate is 8.75%. So I actually found B. Now for the A, I'm going to put the A over here. You basically are saying B equals e to the k because you're converting to the other formula, and you already know A is 10,000, so I put B equals e to the 0.0875 in my calculator. All right. When I do that, you're going to get 1.0914. So my formula here is y equals 10,000, 1.0914 to the t. So you converted that, and then when I get rid of the 1 and move my decimal place, it's 9.14%. So you can convert, you can do the other one first, but to me that's easiest. So the C part, which I'm going to put over here as I'm running out of room, it basically says, why are the answers different? They're different because, and I don't want you to say because 8.75 is continuous. It's because of the continuous growth, 8.75% continuous growth, which is like, and you can say it this way, it's like having like compound interest on your interest. Therefore, at the end of the year, which is your annual rate, it yields a higher interest rate. Oh, I can't spell rate. Interest rate of 9.14%. So just make sure you can say your own words. You can say it's like compound interest, but basically I'm going to have you come up with a formula, convert to the other one, either way, and then you got to tell me why they're different. Okay? Number 6. Okay, number 6 is another one that I really want you to do, and sometimes the shorter questions are the trickier ones, so I'm going to kind of set this up a little bit for you. And it says if 19% of a radioactive substance decays in 7 hours, okay, what is the half-life? So right off the bat, I have people who want to do half A and all that kind of stuff. I don't want you to do that. I just want you to come up because I do not know the rate. So let's kind of do a picture first. So here's my radioactive substance. I have 100% of it. This tells you in 7 hours, 19% goes away. So now I'm left with less. Well, if I take 100 minus 19, I have 81% of it left. Okay, so if we're talking about in our problem and we don't know what it is, if this is A, we can say 1A. This will be 0.81 of A because I start out with 100% or a whole A, and now it's only 81% of A. So before I start this, I want you to look at it and kind of set it up this way that I need to know my formula, so I have to figure out the rate even before I do the half-life because I can't do it unless I know what that is. So I'm going to use y equals a e to the kt, and I'm going to use what I found up there in my gorgeous little picture there. So I start out with A. I have 0.81 of A left, and the 7 hours is easy. That goes in the T spot. So I'm going to do E, and I'm just going to switch their places to the 7K. I'm going to divide, all right? And when I do, I get 0.81 equals E to the 7K. And I'm going to natural log both sides to solve for K. So I have 7K equals a natural log of 0.81. So K equals a natural log of 0.81 over 7. And when I do that, I get this. So the natural log so I'm doing this on my calculator right now. So the natural log of 0.81 divided by 7. And when I do, I get 0.0301. So, and it's going to be negative. Okay, so now my formula is y equals AE to the negative 0.0301. So that's why you heard me hesitate, because I knew it was negative and I was looking at my calculator and I didn't see it right off the bat. Because if it's decaying, K has to be negative. Now and only now do I start doing the half-life. So I want to know how long it takes for half of it to go away. Once I know the rate, I can figure that out. Okay, so I'm going to say thanks for playing. So I have a half equals e to the negative 0.0301t. And I'm going to natural log both sides. And thanks for playing. So the natural log of a half equals negative 0.0301t. And I'm going to divide by that. So t equals a natural log of 1/2 over negative 0.0301. And when I put that in my calculator, I'm going to get something close to 22.9 or 23 hours. And that's how long it takes for half to go away, even though I never knew what I started with. So let me recap. First of all, this is a very short question. I had to set it up like this because I never told you the rate. So I kind of drew a little picture. I put in all the information that I had, that I start out with a whole A, got down to 81% of an A, and it took me 7 hours. So I can figure out what the continuous decay factor is. I have no idea. When I do that, I found out it's continuously decaying 3.01%. Now, once I put that in my formula, now I can say what's the half-life and solve for T, but I can only do it then. Okay, so I hope this helps you with your homework problems. If you have a question, please make sure you get a hold of me.